Alright guys, we're looking at the topic C quiz. We're going to be taking this test on Thursday, September 26th. So we're just going to walk our way through the study guide so you're prepared for your test. The first thing it asks us to do is indicate the location of each point. I always like to draw out my quadrant. I have quadrant 1, which we know is positive, positive. Quadrant 2, which we know is negative, positive. Quadrant 3, which is going to be negative, negative. And quadrant 4, which is going to be positive, negative. We know that if anything falls on our x-axis, our y is equal to 0. And if it falls on my y-axis, my x is equal to 0. Now we can go in and we can start marking which one each of these points fall in. So if I'm looking at point P, I have a positive and negative, and we can see that that falls in quadrant 4. Now I'm looking at a positive, positive for Q, and we know that falls in quadrant 1. Next, I have a negative, negative for R. We know that is going to fall in quadrant 3. For S, I have a negative, positive. So that would usually fall into quadrant 2, but we have to remember that's not a positive, that's a 0. Now I said if my y is 0, it falls on the x-axis. So I'm going to go ahead and I'm going to mark off x. And lastly, we have t, which is negative, negative. That's going to also fall in quadrant 3. And that is it for problem 1. If you need to go and label so you can remember, your quadrant 1 is going to be positive, positive. Quadrant 2 is going to be negative, positive. Quadrant 3 is negative, negative. Quadrant 4 is positive, negative. For our x-axis, you're going to have your x can be anything and your y is 0. Your y-axis is going to be 0 and then any y. That'll just kind of give you a reminder for tomorrow. Now let's look at problem 2. Problem 2 wants us to use the graph to complete parts A, B, and C. So the first one we're looking at is part A. And part A wants us to write an answer from our answer choices down here. And we're going to make each statement true. So first we are looking at point J. And point J is going to be this one right here. And it wants us to figure out what it is a reflection of, and the original point is going to be across both axes. So if I remember, when I am talking about reflecting over two axes, so we're going to look at first, J is 3, 2. So if I reflect over my x-axis, I'm going to go ahead and write it up here. X-axis, I change my y. If I reflect over my y-axis, I change my x. And if I reflect over both axes, I change both. So if I'm changing both, I am looking at negative 3, negative 2. And if I go 1, 2, 3, down 2, I end up at H. So I'm going to say H here. Next, I have point D. And for point D, I'm talking about it being a reflection over the x-axis. If I look back up here, I just said if I'm reflecting over my x-axis, I am going to change my y. So first, I need to know that point D is 7, 7. So if I reflect over my x-axis, I need to change my y. That's 7, negative 7. And let's go find it. I'm going 7 to the right and 7 down. And that is going to give me E. Now it says when blank point is reflected over the y-axis. So I'm talking about my y-axis this time. The ordered pair is negative 5, 5. I'm sorry, negative 5, negative 5. We're going to go back to the top, and we're going to remember that when we're talking about our y-axis, we are changing our x. So I am looking for a point that is going to be 5, negative 5. So I go 5 to the right, negative 5. I'm going down 5. And the point that I come to is point G. So I am using point G here. Point blank is in my quadrant 3. So we know that this is quadrant 3. If we go and we label our quadrants, I have 1, 2, 3, and 4. So I'm talking about point H again. And on my y-axis, so if I go and I highlight my y-axis, I only hit one point, and that is point L. That's it for 2. Don't forget, this up here is going to be super important. When we reflect our x, we change our y. Reflect over the y-axis, we change our x. If we're reflecting over both, we're changing both. Now we're moving to part B. Part B, we are back talking about point H. So before we even get started, I'm going to flip back to my part A. I'm going to go to point H, and I'm going to remember what H was. And we said H was negative 3, negative 2. So here I'm going to write H is negative 3, negative 2. And now I'm going to go and I'm going to fill in all these questions. It says circle the answer choice from each list to make each statement true. Starting at the origin, we know origin is 0, 0. And I move 3 units to the 1, 2, 3 to the left. And then I need to move how many units up or down? So if I go back, I see that I am moving 2 units down because I have a negative 2. And we know that when we have negative if we have positive numbers, they go to the right and up. Next, we have part C. Part C says Leo is working with the point 5, 5. He's saying it's a reflection of point G across the y-axis. But at Dash, he says that point negative 5 is a reflection of G across the y-axis. So we're trying to figure out who is correct. So first, let's go look at what G is. And I had it written here. So we know that the reflection is negative 5 over the y-axis, which means that G must be 5, negative 5. All right, so let's go back over here. We have G, and we know that G is 5, negative 5. So let's go answer these questions now. Who is correct? What is a reflection of G over the y-axis? So if you remember what we wrote up here, whenever I reflect over my y-axis, I change my x. So that would give me negative 5, negative 5. So that means that a dash is correct because the x's are opposites. If Leo were to be correct, that would be flipping over the x-axis because I changed my y. And if we look right here, this problem actually gave us the answer. If you need to double check yourself. Moving on, we're now on number 3. Number 3 wants you to write the coordinates of each point to complete the table. So again, if you need to label, go label your quadrants. This is going to tell us what kind of points we have in each one. I know I have positive here. negative, positive, negative, negative, and positive, negative. First, I'm looking at point A. So for point A, I am going to the right, which is going to be positive, and I'm going to the right 6, and then I'm going up 2. So I'm going to call that 6, 2. Next, I'm looking at point B, and for point B, I'm in quadrant 2, which means I'm starting with a negative, and that would be correct because I'm moving to the left 3, which I'm going to call negative 3, and up 7, which gives me a positive 7. For point C, I'm moving down to quadrant 3, so it should be negative, negative, and that is right. I'm moving to the left 5, 6, 7, 8, giving me negative 8, and down 1, which gives me negative 1. And lastly, we are looking at point D. Point D is in quadrant 4, so I should be getting a positive, negative. Moving to the right 2, which gives me a positive 2. Then I'm moving down 1, 2, 3, 4, 5, 6, 7, 8, giving me a negative 8. And that is it for number 3. We can now move on to number 4. Number 4, we're talking about point A, which is at negative 4, 8. Negative 4, 8, and we want to reflect it over the y-axis. Again, we're going to go ahead and make our note that if I reflect over the y, I change my x. If I reflect over my x, I change my y. And if I reflect over both, I change both. So let's see. And if you need to remember, an ordered pair is always written x, y. So point A is a reflection of blank across the x-axis. Across the y-axis. So I'm going across my y-axis, which means I need to change my x, giving me 4, 8. And if I come down here, that is D. Point A is a reflection of blank over the x-axis. So if I'm working with a reflection of my x-axis, I need to change my y, giving me negative 4, negative 8. If I look here, that gives me C. And lastly, I am flipping both. So I'm reflecting over both axes, and that means I need to change both. So I'm at 4, negative 8. And that gives me B. And at the bottom, we're on part B now. They want us to do 2 things here. We always need to remember, if we're plotting, we are labeling. So that's 2 steps. Firstly, I have A, which is going to be negative 4, 8. So I'm going to the left 4 and up 8. And make sure you label it. B, I am going to the right 4. 1, 2, 3, 4. Then I'm going down 8 because I'm negative. 1, 2, 3, 4, 5, 6, 7, and 8. And I'm going to label it. I'm going to go ahead and erase these marks. So I just wanted you to be able to see that I was counting. Now I'm looking at C, and I'm going to go negative 4 and then negative 8. So that is going to bring me right here. And I'm labeling it. And lastly, I have D, which is positive, positive. So I know I'm looking in quadrant 1, which is my upper right-hand corner. I'm moving to the right 4, and then I'm going up 8. That's going to put D right here. Don't forget to label it. Now we're done with all of number 4, and we're moving to our last problem, which is number 5. For number 5, we're talking about point P, which is at negative 4, negative 3. And we're going to talk about point Q, which is at negative 4, 3. So here we need to know point P is a reflection of point Q across which axis. So looking at it, my y's are different, meaning it's across the x-axis. Then it wants to know the distance from each point to the y-axis. Remember, we have x, comma, y. If I look at my coordinate plane, my x is going to show me how far I am moving away from my y-axis. So if I'm moving 1, 2, 3, 4, or negative 1, 2, 3, negative 4, that is how far I am away from my y-axis. We also know that distance from 0 is absolute value. And absolute value will not be. So I can go ahead and I can mark off my negatives. And I'm looking at my x to see how far I'm moving away from the y-axis. And I have 2, 4. So that's going to be 4. Now I'm going with my x-axis. I want to know how far is each one from my x-axis. So I'm moving 3 up and 3 down. No, it can't be negative, so it must be positive 3. Now I want to know if they are on the same or opposite sides of my y-axis. So if I go and actually plot these, I have negative 4, negative 3, which is P. And then I have negative 4, positive 3, which is Q. So they are on the same side of my y-axis, which is right here. And I can tell that because both of my x's are negative. If both were positive, they would also be on the same side, just the opposite side. If one x were negative or one x were positive, they would be on opposite sides. But since I have two negatives for my x's, that means they are on the same side of my y-axis. And that is going to be all for this quiz. Just a reminder, we do have our test on September 26th, which is Thursday. See y'all then.